Well, welcome everyone to the main part of the lesson today for day 5. What are we taking a look at? Well, actually to start with, just a little flashback in time. These are some things we made note of yesterday. Anything to the power of 0 is going to equal 1, at least anything we deal with here in Math 10. This second fact here, we used actually in our warm-up question. Whenever you move something from the top to the bottom, the numbers all stay the same, just the sign of the exponent changes. The exponent only, not any other negatives, not any other negatives that might be there. Exponent only changes. We used this one in the warm-up. Notice the inside is upside down. And so the exponent changes from a negative to a positive. This one, these were questions given yesterday or part of the lesson. Just to show you how the exponent works, reminder, this exponent is on the, oh, doesn't come up nicely. It's on the x only. So this would give 2 over x to the 3. 2 over x to the 3. While the other question gives you, it captures the 2 inside the brackets. So it gives you that, which can be taken to, as a final answer, 8 over x cubed with a step in between that you could remind yourself with. If you forget, you can take a look at last day's lesson. And if it still isn't good, hey, come and let me know. Okay, I'd like you to stay up to date and be like, oh yeah, I know why it goes from there to there. Okay, if not, hey, you let me know. Another example from last day. Again, just moving the negative exponents underneath and everything else stays on the top. So that would give an answer that looks like 5y cubed all over x squared z to the 4th. This one used a couple of the examples that a couple of rules that we saw. This will turn upside down, and then the 4 goes into each thing. So it goes upside down, making a y cubed on the top, x squared on the bottom. Because it's upside down, it's a plus 4 now. And then to finish up, each thing. This 4 goes on to the y cubed. This 4 also goes to the x squared, and they get multiplied together. Again, kind of like this earlier question. Yeah, there's a step in between. Make sure you have it. If not, review the video. And if not, if that still doesn't work, then you let me know right away. Super important. Then we did this one. A bit big to go over all together here. Best to check last day's video. But you simplify the inside first. Get all the x's together. Flip it upside down to get rid of this negative here. And then lastly, apply the 2 to the terms that are left on the inside. Okay, so you check that out last day for the optimal effect. But hopefully that's, if you practice, hopefully that's enough for you. Simplify the inside. This x goes down. These y's, this one goes down, that one goes up. This z goes up. Simplify the inside. Flips upside down. Gets rid of the negative. And then the 2 goes in to the pieces that are in there. Which now, hey, brings us to today's stuff. So what we're looking at here are exponents that have fractions in them, just like we worked on, okay, in the warm-up question. Now, I'm going to add it in here. Another word for fraction, or in fact, professional word, is rational. Okay? Rational exponents. If you see this word show up, it just means fractions, like we've been working on. Now, in order to simplify, in order to work with these types of expressions, fractions in the exponents, here are some useful bits of info that can help you with the process there. So the first thing to do is to take whatever numbers are there and find the prime factorization like we did our first day together. You either make a tree, or you can do repeated division, but then at the end of the day, you get a big list of numbers that you can combine together to get the exponents for. Okay, so prime factorization first, do that first. Next, exponent rules. There are a few of them, but these ones in particular are going to be used for this topic. Okay, so each thing inside. What the heck is this talking about? So the each thing inside, that's talking about this situation where you got an x squared z4. See, and this is a 6. That's a 4. Each thing inside, this 6 goes to each thing on the inside. This is a rule, one of the rules that's going to be important with this. All right, each thing, one for the x, one for the y, one for the z, each thing gets that 6. And if you want to work this out, final answer just for fun, x18, y12, z24. Yeah, but this is kind of extra. The focus is the fact that this exponent goes on each thing. We're going to use that. The second exponent law that's important in this section is the multiplying through the brackets. So if you have x5 and the 7 like this, right? This situation, well, it comes up all the time. So you need to know what to do. What do? Multiply them. X to the 35. Okay, so those are the two exponent rules, or two of the exponent rules that we'll be using. And lastly, of course, arithmetic for fractions. Okay, usually multiplying. Adding, subtracting, maybe not, but you know what? They're important skills to have, and so that's why we took a look at them. But the arithmetic for fractions, definitely multiplying. All right, so here's some examples. You gotta simplify these things. So, with the 8 to the power of a third, or to the power of 1 over 3, 8 to the, that means it's the exponent, 8 to the 1 over 3, well, what do? Prime factorization first. Okay, so you could, I might do it right here. 8, what does it switch to? 2 and a 4. What gives you 4? 2 and a 2. So 2 times 2 times 2 is the same as 8. In other words, 2 to the power of 3. Okay. You want this version when working with fractional exponents, rational exponents. Because next thing you can do is you replace the 8 with this improved version. the update. Okay, that takes the place of 8. 1 over 3, that's still there. And now, as I promised, I wouldn't lie, you got a bracket on the, or bracket in between one exponent and the other. So these now get multiplied together. Now, what didn't come up in our warm-up question is when you just have a single number like this. What I want you to remember is that there is an invisible 1 underneath. And I don't want to write it here. It's just going to look all junky. But I will write it here. Okay? The step is 3 over the invisible 1 times 1 over 3, like that. Okay. Multiplying fractions, we did it in the warm-up. Okay. Top times top, bottom times bottom. But also simplify whenever you can. You see? A 3 can divide that, a 3 can divide that. So those can divide out and leave you with 1. 3 divided by 3, 1. 3 divided by 3, 1. So all you're left with is 1 times 1, 1 times 1. This whole thing's going to be 1 when you work it out. Okay, but I'll show, because the numbers are small, I'll just work it out without any simplifying. Top times top, 3 times 1 is 3. Bottom, 1 times 3, 3. So you simplify. 3 divided by 3 is 1. That's 2 to the 1. And because it's a 1, we don't write it. And so we get our final answer looking like this. And so to be professional, check this out. 8 over 1/3, the original question is equal to what? That's equal to 2. So just like we suggested, prime factorization to get an exponent. Start using the exponent rules. Being careful with fractions. Success. Take a look at the second example. There's a variable in there, the x. Yeah, just works in the same way. Okay, we'll attack this in the same manner as the other question. 1 over 2. So the 16, if you know what it is, then skip right over to it. And what I mean is the exponent version of this. If you know that, then just go right ahead. But if you got to work it out, well, then you got to work it out. Okay, so 8, oops, that's the earlier question. We got 16 now. 16 is the same as this 2 times that 2 times that 2 times that 2. So 16 is the same as 2 to the 4. So we can improve this now. 16 is replaced with 2 to the 4. That stays, we haven't worked with it yet. And that stays, we haven't worked with that yet either. So now we don't do any multiplying yet. We do each thing inside. Okay, so the one thing, there's 2 things inside rather. 2 to the 4, x to the 4. So that'll be the 2 to the 4 bracket. That'll be the x to the 4 bracket. They each get the half that is there on the outside. Well, let's put these in there. That's a 4. That's x to the 4. Okay, so we use the each thing inside. Now we do the multiplying because we have exponent, bracket, and exponent there. So just showing you in slow motion here, we got 4 times a half. So remember, this is 4 of the invisible 1. So that's going to give 4 times 1 on the top. Invisible 1 times 2 gives 2 on the bottom. That's going to be the same with the x's. Invisible 1 on the bottom, right? So 4 on the top times 1 on the top is 4. Invisible 1 times 2, 2. Simplifying, working it out, trying to keep it neat. 4 divided by 2, remember these are exponents, not like mixed number stuff. 4 divided by 2 is a 2. So that's upstairs as an exponent still. 4 divided by 2, that is upstairs as an exponent still. All right, so you can simplify the number. 2 to the power of 2, 4, x squared. So as a professional looking final answer, what is this thing? That is equal to 4x squared. Done. And see, all that happens is we make the numbers a little bit bigger. Maybe throw a negative in for a fraction. It's one other rule to remember. You know, we don't have a 1 here anymore. We got a 2 upstairs. So the fractions on the outside is a little more complicated. But you know what? It's just all the same. Same style. Just got to watch. As you can see, it's starting to get a little messy here. And when it gets messy, that's when mistakes happen. So I'm going to try and be careful when I show you the next questions. You try and be careful when you do them. All right, so making it look good. Here's what we got. 27, x to the 6. And then, yeah, what's going to happen is when you start writing these exponents, they're going to fall down into the main part of the question. And that's going to cause some trouble. Okay, so what I want you to do, we've got to do the prime factorization first. So I'm going to leave that to you to do. And I'm going to give you a hint though. 3 goes into 27. You got to figure out the number. Okay, so what I'll tell you for free though, once you get the answer, 27 is going to be the same as 3 to the power of 3. That's what you get for the prime factorization. So I'm going to put that in here. The improvement, the update. 3 to the 3, or 3 to the power of 3. Still 2 over 3 on the outside. Keeping it up in the exponents there. And also trying to get rid of that hole there at the top for you. Okay, that looks good. The next step is to apply this exponent to each thing on the inside. So that will look like this. The first thing gives 2 over 3. The second gets 2 over 3. 3 to the 3, x to the 6. Doing the multiplying. We can do some canceling here. And also I'll take a step and hopefully, as you saw, won't run out of space. We have 3 now times 2 over 3 for that first exponent there. And that's going to be times x to the 6 multiplied by 2 over 3. Okay, and so notice that these 3's, one's on the top, one's on the bottom, they can divide out with one another. And that leaves 3 to the power of 2 only. Watch this. 3 divides into both 6, which is on the top, and 3 on the bottom. So those will divide out. And you'll be left with 2. This 2 comes from the 6 and the 3. This 2 is still there, so bring it down. And that gives the final result here of 9. And then over here, it'll be x to the power of 4. Okay. In the interest of real estate, I'm just going to leave it right there for you. Okay, but just as a reminder, just quick overview again. We had the 27, got the prime factorization. Careful with the writing, keep the exponents in exponents. But we use the rule where each thing gets the exponent on the outside. Fraction work with canceling. I didn't do it earlier because it'd be messy, but watch. It's 3 divided by 3. 3 over 3, so those are gone. Leaves the 2 only. 6 and the 3, that leaves a 2 there. Okay, so that creates that 2 like this. From there, you work it out. Success. Okay, so challenging question number 1 with rational exponents. That was good. Let's do this one. Notice the numbers are similar to an earlier question. 16, you can go and take a look at the prime factorization. The only thing now is we have a negative in there. So here's the thing. Well, this is on the top right now. And so when you move it to the bottom, this negative will go away. But what that means is we create a fraction when we do this. So I don't want to do that to start with. I'll do it afterwards. Okay, so for this question here, we're going to work with that negative later on instead of right at the start. 16 though, for the prime factorization, 2 to the 4. Okay, if you don't believe me, choose your favorite method, repeated division, factor tree, that can work out. So we improve the expression. Improve because there's an exponent there. Negative a half like that. You see? Now we still have this negative, so tempting to put it all underneath, but nah, just wait. Okay? Let's give this exponent to each thing first. It'll mean a little bit of multiplying, or extra multiplying, I believe. But it's safe, and you will be less likely to make a speedy mistake of some sort. All right, so we have this as usual, goes to each thing on the inside. Multiply through. You see, maybe even now you can start seeing that this is on the top, that's on the bottom. So you have a 4 over 2. So those can divide out. And then what are you left with? 4 divided by 2 is 2. 2 times negative 1 will give a negative 2 there. Okay. If you can follow that, then cool. Very good. If not, then just write this down just to be super careful. See, so 4 on the top, 2 on the bottom, they can divide out. That creates the 2. 2 times negative 1 creates a negative 2. But really, if you don't like that, you can just keep multiplying through. Top times the top, negative 4. Invisible 1 times 2, 2. This term ends up getting 2 to the negative 2. Over here, it's really the same situation because it's just an x instead of a big 2. So here, I'm going to take the top times the top and get a minus 4. Invisible 1 times 2, I get a 2. That creates x to the negative 2, and then Yeah, just bringing it down like that. Now it might look finished. It's definitely simpler or closer to our answer than before, but usually we want positive exponents. So that means we have to take it further. That means we can now put each of these things, each of these terms onto the bottom. Okay, so I'm going to continue here. Hopefully your page is a little neater than mine. This 2 to the negative 2, that turns into 1 over 2 to the 2. This x to the negative 2 turns into 1 over x to the 2. You know, and officially they are separate fractions. You know, it's this term times that one. So it's this fraction times that one. But once you get comfortable with this, right? 1 times 1, 1. It all just combines into one fraction. On the bottom is 2 squared, which is 4. And then 4 times x squared is x squared. And so that is the final answer for our original question up there. And so where are we now? Well, after your good hard work today, have a longer warm-up and the lesson, this takes us to the end. So for you are these 1, 2, they're 3 worksheets, and they're all in teams for you to take a look at. And I believe it comes up there. Yeah, fair enough. So look, this is day 5 for you to see here. This is the overview as usual, so you can check that out. Little introductions, important videos to watch. And then these are the 1, 2, 3 worksheets that are there. Really, just for practice, adding, subtracting fractions, multiplying, dividing fractions. Okay, use your brain, not your calculator if you don't mind. Although, of course, I can't tell from being over on this side of the world. And then lastly, this sheet here has to deal with today's topic. All right, so I'll leave that for you. Thank you for stopping by. Of course, complete your homework, submit it in the usual way by email. And be sure to get caught up if you haven't submitted the earlier work. And if you have any questions, then send an email. We can arrange a time to work together. All right, so take care, and I'll see you at the next session. Bye-bye.